So in this question, you have, this is the magnetic field, and magnetic field is perpendicularly outward. And this is the rod that is rotating like this. So obviously, this is a case of motional EMF. And this rod is rotating like this, and you have to tell me what is the EMF. Okay, induced EMF between P and Q. So take EMF as potential difference. Okay, so P and Q. Now check what is happening. Suppose P will enter here and up to this P will be there. So what will happen? Take a charge here, suppose plus Q. This charge is moving like this. This is the velocity. And magnetic field is outside. So if you take V cross B, positive charge is this side. So P will be at higher potential and Q will be at lower potential. So from here to here, P will be at higher potential. And now suddenly Q will have that advantage. Okay, so if you see VPQ, what will happen? Obviously, either option this will be correct, this will be, or this will be correct, because you know your motional EMF will be BVL. Okay, and to derive the actual relation, I will have to take a small part, because this small part is moving in a straight line. Otherwise, this length is rotating. Correct? So initially P will be at higher potential, and after one cycle, one half cycle, Q will be at higher potential. Okay, so if you say EMF between P and Q, so it will be EP minus EQ. So initially EP minus EQ will be greater than 0, and later on EQ minus EP will be greater than 0. So in one half cycle this will happen, and in another half cycle this will happen, right? So what is the correct option? A is the correct option. Okay, so A is the right option. And if you want to see actually how the EMF is developed for a rod which is moving in a magnetic field, that is very nice explanation I can show you. Just see this. Suppose there is some rod, and this rod is rotating in a magnetic field. This region has magnetic field. Okay, so you know the formula DE is equal to BVDL. Suppose there is a small length, so how much EMF will be induced if this is rotating with omega velocity? So what you do, because you know this formula, at a distance x, take a very small length dx. Now this dx length has velocity v, so I can get induced EMF on this, and that induced EMF is given by bv dx. Okay, now this v is equal to x omega, so it will be, because v is equal to r omega, so this will have x omega dx, and total EMF will be b omega integral x dx. Suppose this is center and this is radius capital R, so it will be 0 to r, so it will be b omega r square by 2. This is the EMF, correct? So this is how you can calculate a rotating rod in a magnetic field. So this is rotating rod in a magnetic field. Depending on magnetic field is perpendicularly outside or inside, you will have different potentials. Is that okay? That will depend on the direction of the magnetic field. Okay.